So let us stop here, and let us then move back now to the electric motor, because we still want to look at the components and we want to look at more detail how it works, as well as the application of the principle that we've just gone through. So I'm going to go back to my example of the electrical motor. There we are, and I'm on the electrical motor. How do I know this is the electrical motor? Guys, you look at this section, the external circuit. I can clearly see there is a cell. Normally, when you get it in the exam paper, it will be a long line and a short line there. All right, so don't worry about the way that it's indicated here. This is what we call an applet, or a simulation of an electrical motor. So that is the reason why I just make you aware of the fact that we will use the normal convention. But the moment when I see electricity is supplied, I know this is the electrical motor. Fleming's left-hand motor rule, I can use that. The motor effect is the principle. Now let's look at components. In this case, we have a magnet. The north is the red, the south is the green. So that's why the magnetic field, the blue lines, is from north to south. I'm taking it out, I'm putting it back again. Now in the drawings that you might get in the exam, those field lines will most probably not be in there. So a question can be, complete the diagram by indicating the magnetic field lines. Then you just draw it from north to south. Very easy, and you show the direction. You might only have an N there and an S there, and I still will know that my index finger will have to point from north to south. All right, so if we go to, I can change the direction of the cells. It's one thing that I can change. That is my external part. Here we have what these 2 points there is the brushes. Now what is the reason for having brushes there is that it completes this external circuit with this internal part. This part that can turn, we call it the armature. All right? And it's made of lots of windings of electrical conductor. All right? So that the current can flow through it. All right? So in this case, I'm just showing a single winding. And this part is called the armature, and it can turn. All right, then we've got a very important part here. Those 2 parts there, that is like a semi or half circle, 2 half circles. That part we call the split rings. And you just think about a normal ring. All right, so if I have a normal ring, I divide it into 2 parts. I've split the ring in 2. So whenever you see that circle, that is your split ring. And it just makes sure that there's no short circuit between those 2 brushes, so that the electricity have to take this route. It will go in there, it goes through this bottom half of the split ring, then it goes into the winding, and it can only go out on the top part through that split ring, through the brush, and my circuit is complete. So that is a component which we call the split ring. All right. So what we will also find there now is that I've got my magnet. That is my last part. And then we've gone through all the components. Let me give them again. The external circuit with the cell, my brushes, which is there to complete the circuit, my split rings, and then my armature, which can turn, and my magnet. So we've gone through the components. Now let us look at the working of it. And as this, I'm going to let it resume now. I've paused it. I want you guys to check. Let us take away the force that it's experiencing. I only first of all want to check what is happening in the internal part of the circuit, in the armature. What is happening to the direction of the current flow? And I want to compare that with the direction of the current flow in the external part. Let's see if you can deduct the principle that we will see here. when I resume. Keep a close look at what's happening in the direction. Now, if I pause, this arrow is pointing in that direction, this one is pointing in this direction. But as it turns, this part is going to go to the bottom part. So keep your eye on that part and see what's happening when it reaches the bottom part. Right, when it's there, there's a short while when there's no current flowing through the circuit. The reason for that is that when it's on that specific point, it's not touching either of the two split rings. So my circuit is not complete. So for this moment, there's first of all no current in this armature. There is no force. You can see if I click on force, no force indicated. And the only thing that is still there will be my magnetic field, because I haven't changed anything to my magnet. All right, so for that short moment, there is no force. There's nothing that actually forces this motor to turn, because there's no force. But why is it still turning then? Momentum. It's got momentum as it is turning. So the momentum takes this armature through this part where there's no force. So I'm going to resume again. The momentum takes it through, and there it is through. Now look at the bottom part. Can you see that when it reaches the bottom brush, there's a change in direction of the current, so that the current actually then stays the same as what it was. So the top part, it will stay in that direction. The bottom part will stay in that direction. So just keep a close look now. Let's go through it there. It's in that direction. This part is turning around. And the moment when it gets down, there you can see the current have changed. So the function of the split rings is that every 180 degrees of turning, I will see a direction change of the current in the armature. All right, I'm saying it again. Every 180 degrees, there's a direction change of the current in the armature. And that is why what the split rings is doing for us. All right, now why do we want that current direction change every 180 degrees? The reason for that is so that this armature keep on experiencing a force in the same direction, where this then will give us continuous motion. My electrical motor will keep on turning in the same direction. If I didn't have split rings with a direct current source here, then this armature would not have a continuous turning motion. All right, so I'm going to put everything on now. Let's now add the force. You will see the top part is experiencing a force in that direction, and the bottom part a force in that direction, and it's because of the direction also of the current flow together with the direction of the magnetic field. So let's take it through 180 degrees now. So that top part is going down now, and the moment when it is down, it's experiencing the current flow have changed in it, so the force stays in that direction. So in this case, it continues to move in a clockwise direction. So I like this application because the more you look at it, the more you work with it, you start to understand the combination of the three things which is in the principle. There is the force experienced, there is the current, the magnetic field, and the current direction. So I'm looking at those three factors the whole time to understand what is happening there. Most importantly, I can apply my rule to see if this is correct. If this direction is correct, I can use it to see if that is the direction I would find. Because what do I have here? I have two of the three things. I've got my magnetic field and I've got my current direction. So if I apply this, you will see that your thumb is showing in this direction, coming to the right. So that is the direction of the force. So I can apply my rule. I'm understanding the components. I'm understanding the function of the components. Let us just recap on that. Why split rings? The split ring will change every 180 degrees the direction of current through the armature. That will result in a force being in the same direction for the whole 360-degree turn, which will give me continuous motion. All right. Now, where will we find applications all around us every day? Let's think of a drill. A drill where I want to have a hole in a wall to hang up something, maybe a portrait or something. It's very important that that drill have a continuous motion. If you think about your hairdryer is rotating in the same direction so that it creates a mechanical force, and that can have airflow through your hairdryer. There's so many examples of machines where you have continuous motion, where you just supply the electricity, where electricity is converted to mechanical energy. But I've just mentioned two. And the uses is if you look around you in your home, you will come up with many more examples. I've just done two with the hairdryer and the electrical drill. All right. These days you get electrical screwdrivers, where it's important that it must have a continuous motion in one direction. Now, in the case of screwdrivers, if I want to change the direction of the screwdriver, what do I need to change here to make sure that the screwdriver can either drill the screw into the wall or out? The only change I need to make is I need to change the direction of the electrical current. If I change the direction, just look what's happening with the direction of the force. I'm changing the current direction now. You can see the plus is now at the top. Can you see the force is now into the page? If I'm changing it back, the plus is now at the bottom. My force is in the opposite direction. So that changes. I can have a change in direction, which will have a change in force, and my drill will then operate in the opposite direction. All right, so that, people, is the electrical motor. Let us go back to our PowerPoint at this stage. So if we look at the electrical motor, can we now say we are quite happy with the following? We did look at the components and the reason for that specific components. We did look at the principle on which it's functioning, the motor effect. We did look at the energy conversion. We did look at uses, and we did look at the explaining of how it is working. And there I'm using that left-hand motor rule to a great effect, as in this example as well. All right, so at this point, I'm going to give a short break of 5 minutes. If there's anything that the teacher would like to recap or emphasis again, this is your opportunity. So let us have a short 5-minute break. Then we will proceed on to the generator, and you will see it will start to go a little bit faster from here on in. All right, thank you guys. I'll see you back in 5 minutes.